In this video, we're going to be talking about section 6.6. We're going to break this into two different videos. So this will be the first day. We're going to be talking about factoring polynomials, but this time we're going to have polynomials that have a coefficient labeled a. So the a value is going to be now a number that is not 1, and we get to learn how to deal with that. So we're looking at having a specific number there. All right, in our warm-up today, we're going to do some basic factoring that we know how to do, but you'll notice our first one has a 3 there in front of the x squared, not just a 1, like all the ones we know how to do. So this is the exact type of thing that we're going to learn how to do today, but I wanted to put this one on here because I wanted to remind you that the very first step in factoring should always, always, always be check to see if there's a common number that you can factor out. So we're going to look for the greatest common factor, and 3 will go into all 3 of those numbers. So we're going to factor a 3 out, leaving me with x squared plus 8x minus, let's see, 3 goes into 14, 4 times, carry the 2, 48. So now I'm looking for the factors of 48 that are going to subtract to be 8. So we're using all the rules that we've learned previously. So 1 and 48, 2 and 24, and 3 and 16, 4 and 12, 6 and 8. But we've already found it because we're looking for numbers that will subtract to be 8, and that would be the 4 and the 12. I want it to be a positive 8, so the 12 is positive, the 4 is negative. Remember, when this sign at the end is negative, the only way that's possible is if these signs are opposites. So we're going to bring that 3 down, and then we're going to factor into two binomials where we have x minus 4 and x plus 12. All right. So what we'll be doing today is looking at ones where, like this one, you could factor out the 3. We're going to be looking at problems where you have to deal with that 3 as it is. All right, so let's look at 2x minus 10 is 2x minus 2 times 5, right? And so we can factor the 2 out, leaving us with an x minus a 5. So once you identify, that you can factor out a 2, then the stuff that's left over, the x and the minus 5, becomes x minus 5. All right. On this one over here, we can factor out only a y value, leaving me with 5x plus 13. Once again, we identified that they both have a times y, and so we brought the y to the front. And then everything else, we had a 5x plus 13, 5x plus 13. Always can check your work very easily by distributing the y back in. 5xy, 13y. Looks good. All right, on part D, we can factor a 2 out, I think is pretty obvious. But what I want you to notice is that we have a negative in both terms. So it almost really seems like a better idea to factor out a negative 2. And that'll change the signs on both of these, and it'll become x plus 7. And that's just going to look a little bit cleaner. Plus, it'll be connected to what we do later today, looking to factor out a negative. All right. Now, on this next one, it's going to look a little different than the others, but it really is the same thing. What I want you to notice is just like on B and C above it, how I've identified the common piece. Here we have a common piece. The common piece happens to have a couple pieces in it, but that doesn't really matter. We're multiplying by 2x plus 1. They both have a 2x plus 1. So just like I did on part B, when I identified they both had a 2, what did I do? I pulled that 2 out to the front. We pulled the y out to the front. So in this case, we're going to pull the 2x plus 1 up to the front. Then what's left is an x plus 2. And so we have done exactly the same thing we've been doing. I identified they both had a common factor of 2x plus 1, which I pulled out to the front. And then what was left? X plus 2, x plus 2. So this piece right here is something we're going to be doing a lot of today. So we got to really get comfortable seeing that that is just a common factor. So on part F, we have the same situation. They both have an x minus 7. And so I can factor that out to the front. And then I'm left with an x plus 4. So I get x minus 7 times x plus 4. All right, and then this one looks like we have an x minus 3 in common. So I have an x minus 3 factors out. Sorry for the delay. My computer screen just went to sleep for a second. So we could factor out the x minus 3, and then that leaves us with 2x squared plus 1. Because please keep in mind that there's a little 1 times in front of this, right? So when I take the factor away, there's still something left behind. In this case, it would be a 1. All right, so what this is called factor by grouping. So with factor by grouping, which we're going to make lots of use of today, what we do is we group the first 2 terms together of a 4-term polynomial, and then we group the last 2 terms together. Then we look to factor each of those separately. So it's a little hard to describe in words. I think it's best to just to show it in practice. So here we go. Factor by grouping is very simple. You are going to group the first 2 terms together, and then you're going to group the second 2 terms together. Then what we do is we just treat it as 2 separate problems. So temporarily, I'll put this back in a minute, but temporarily, I don't see this. This is not here. All we're looking at is that first piece. So can we factor anything out of 2x squared plus x? They both have an x. So I can factor out an x, leaving me with 2x plus 1. Check it, x times 2x, x times 1. Everything works. All right, so now that I've done that part, now we're going to do, essentially, scribble all this out, and we're just going to look at the last part. We have a positive 6x plus 3, so we can factor out a 3. For this to look right, I'm going to factor out a positive 3, so I'm going to put a plus 3 here, leaving me with 2x plus 1. And so you'll notice that if this works, if we've done everything correctly, we have this common piece. They both have the 2x plus 1, just like we did in our warm-up above. And so I can factor that out to the front, leaving me with x plus 3. If we do quick FOIL, we can show that we end up back where we started. All right, so let's do the second one. I'm going to group the first 2 together. I'm going to group the second 2 together. In the first one, I can factor out an x, giving me x minus 7. In the back half, I can factor out a positive 4, leaving me with x, and 28 divided by 4 is 7. And so, once again, we have the common piece. And so we'll factor that out to the front, leaving me with x plus 4. All right. Let's try 2 more. This one has a negative in an awkward spot, and I'll explain that. When I group these together, and then when I group these together, the negative is part of that, just like I tried to show you. Notice where I drew my lines on the 2 problems above. The plus, and my clicker's not working, so the plus was attached to the 4x on the previous one. So we're talking about right here. And this plus was attached to the 6x. And notice I did include it in the grouping. So the same thing's happening here. This time I'm going to factor out an x, leaving me with x plus 7. And then what I want you to notice is if all I do is factor out a 4, then I'm not going to have an x plus 7 in the second part. And I need it to match the x plus 7 if I want it to factor. So for that reason, anytime this term is negative, we're going to want to factor out a negative number. So I'm going to divide out a negative 4, and that's going to leave me with a positive x and a positive 7. If I didn't do that, then they wouldn't have matched the x plus 7s. Now that they do match, I can factor out the x plus 7, leaving me with x minus 4. And this last one, same thing, group together. I can factor out a 2x squared out of the first group, giving me 2, nope, not a 2, giving me x minus 3. And in the back half, I can factor out a positive 3, leaving me with x minus 3. And once again, we're done. All right, so the only thing we need to now learn is how do we break a trinomial up to look like these problems? Because you'll notice these are not trinomials, but I also want you to notice that these two, like we could have just combined them back together, right? We could have connected those together and not messed with this. So factor by grouping requires us to take our trinomial and to turn it into something that looks like this. And it's pretty simple. So let's go take a look. All right, the first thing you need to know is all of the rules that we have learned for factoring still apply. In other words, the first thing I should notice is this plus sign right here. And this being a plus tells me my signs are going to be the same in my answer. And this sign is going to be what they both are. So in this case, we know the signs are the same and they're both going to be positive. All right, so we know that. Then we would normally look at the factors of 3, right? And then figure out how to add to get 7. But 3 and 1 does not add to be 7. That's impossible. Plus, I've got this number 2 in front that I got to have to deal with that. So the rules have changed slightly. The only thing we're going to do different at the beginning is instead of finding the factors of 3, what we're going to do first is we're going to do what's known as multiplying a times c together. Now, if you remember, we're looking at something in the form of ax squared plus bx plus c. So when I say a times c, I'm talking about the leading coefficient and the constant. So in this case, we're going to multiply 2 times 3 and get 6. Okay. Now that I have that number, all I'm going to do is use all the same rules I did before. I'm looking now at the numbers that multiply to be 6 instead of the numbers that multiply to be 3. So we're not going to erase the 3. We're not going to do anything like that. We're just going to now focus on the factors of 6. So we have 1 times 6 and we have 2 times 3. So just like before, all I have to do is figure out which ones of these will add to be a 7. And that, of course, would be 1 and 6. I would highly suggest, we know the signs are the same and they're both going to be positive. Let's make it a plus 1 and a plus 6. All right. Now, the only other thing we have to do is we're going to rewrite this math problem, except I'm going to change the 7x into the 1 and the 6, because 1 plus 6 is 7. So here's what this is going to look like. I'm going to rewrite the 2x squared, just write it down. I'm going to break the 7x into, and it doesn't matter which order you put it, a positive 1x and a positive 6x. And then we bring down our 3. Okay, so we found how to make 7, and then we turned the 7 into those two things. Now we are set up with 4 terms, and we can try the factor by grouping. I know this seems like a lot, but 90% of it, maybe 80% of it, is exactly what we did before with some small alterations. All right, so now I'm just going to group together. In the first two, they only have an x in common, so I can factor out the x, giving me 2x plus 1. In the back, I can factor out a positive 3, giving me 2x plus 1, which matches. So then I can factor out the 2x plus 1 to the front, leaving me with x plus 3. So we got our common piece, which we brought out to the front, and then we were left with, in each term, the x plus 3, x plus 3. If we check it, We just FOIL it out. 2x times x is 2x squared. 2x times 3 is plus 6x. 1 times x is plus x. 1 times 3 is 3. 2x squared plus 7x plus 3. All right, so once again, the rules are very simple. I'm going to have to find the factors of, in this case, the factors of 5 times 3. I'm going to have to find the factors of 15. So that would be 1 and 15, and that would be 3 and 5. I know my signs are the same. They're both positive, and I know I'm adding to get 16. So I'm going to have a positive 1 and a positive 15. Now I'm going to simply rewrite the problem, 3x squared. Change the 16x into 1x and 15x, and the order does not matter. And then bring down your 5. So this is me just rewriting the problem. Now we're going to group. I can only factor an x out, so I get 3x plus 1. I can factor out a positive 5, giving me 3x plus 1. So the answer is 3x plus 1 times x plus 5. There you go. Next one. 2 times 7, 14. 1 times 14, 2 times 7. I'm looking to add to get 9. My signs are going to be the same again. They're both positive. So positive 2 and positive 7. Rewrite. 2x squared plus 2x plus 7x plus 7. Group. I can factor out 2 and an x, giving me x plus 1. I factor out a positive 7, giving me x plus 1. The answer is x plus 1 times 2x plus 7. Those are the factors of our trinomial. All right, if you haven't stopped and paused the video and tried them on your own, please do so now. Try the next 3, and then check back in, see how you did. All right, number 4, first step, 5 times 11 is 55. 1 and 55. 2, 3, 4, 5, and 11, obviously. And that's it. But good news, we're adding to get 16, and these do. Signs are the same, both positive. 5x squared plus 5x plus 11x plus 11. Rewrite the problem, change the 16 into the 5 and the 11. Factor out a 5 and an x, giving me x plus 1. Factor out an 11, giving me x plus 1, x plus 1, 5x plus 11. So this time, notice I didn't draw my lines underneath it just because I've got this down. So I just had to visualize what I was doing. Certainly you can do that too when you were ready. All right, this time signs are the same again. We're adding to get 40, but this time we're adding to get a negative 40. So both are going to be negative. 3 times 13 is 39. We're still looking to add to get 40, so 1 and 39 is going to get the job done. But this time it's a negative 1 and a negative 39. All right. If you can help it, we want to, like if you have the choice of not having a negative on that third term, then we can avoid factoring out a negative. But in this case, we can't choose around that because both of the numbers are negative. So we just have to deal. So it doesn't matter which one you put first, the 1 or the 39. For some of you, it might be easier to put the 39 first. I'm going to do the 1 first just because might as well do it, show you the worst possibilities. 3x squared minus an x minus a 39x plus 13, still equivalent to what is above it. If I were to combine those together, I got negative 40. So now I'm going to factor, and then like we did before, I want you to notice this negative belongs to that 39x. So here I can factor an x out, leaving me with a positive 3x minus 1. So when I factor something out on this one, notice it's a negative 39x, so I'm going to have to figure out or factor out a negative number. By the way, there's always a very obvious clue to help you out. Notice I have my common piece, hopefully my common piece of 3x minus 1. So I'm looking over here at 13. That 13 needs to be a 1. So in other words, I need to try to factor out a 13. And in this case, a negative 13. So I'm going to factor out a negative 13, which is going to turn into a positive 3x. Positive turns into a negative and a 1. If you get to this stage and you don't have exactly the same thing, 3x minus 1 and 3x minus 1, then you've done something wrong. It's probably a negative, could be something else. Don't force it and just pretend and look past it. Go find your mistake. All right, so now we're done. 3x minus 1 times x minus 13. And the last one we have right here, I think there might be 3 more below. Okay, 2 times 21 is 42. I'm looking to add to get 13. Once again, notice they're both going to be negative. Sorry, I've hidden the 42 there. Okay, 1 and 42, 2 and 21, 3 and 14, 4 no, 5 no, 6 times 7. 6 and 7 add to be 13, and they're going to both be negative, so negative 6, negative 7. All right, 2x squared minus 6x minus 7x plus 21. Group together, 2 and x, giving me 2x minus 3. Over here, I can factor out a 7, but I need to factor out a negative 7 to get the, I factored out 2. That's an x minus 3. I need to factor out the 7 and the negative because I want it to be a positive x, just like this one. And that'll turn this into a minus 3, which is exactly what I wanted it to be. X minus 3 times 2x minus 7. All right, 3 more to try. All right, the one thing I haven't been doing, which I realize I'm getting kind of lazy because I already knew the answer, but we really ought to stop and make sure we can't factor something out first. Because even if you can't factor all of the number out, like if you can't get rid of that 10 altogether, if you make it smaller, then it just makes the problem easier. So it is worth mentioning and me talking about, look for a common factor. So 10, 17, and 3 are not all divisible by the same number, so this one has none. And so we'll deal with it as it is by doing what we've been doing. 3 times 10 is 30. I'm looking to add to get 17, so I know it already. It's going to be 2 and 15. Signs are the same, both negative. So I'm going to rewrite the problem, dropping in a minus 2x minus 15x, which makes negative 17x, plus 3. In the front half, I can factor out a 2 and an x, giving me 5x minus 1. On the back half, I can factor out a 3, but I need to factor out a negative 3 to turn that negative 15 into a positive number because I want it to be a positive 5. So factoring a negative and a 3 will accomplish getting that to be a 5x and this to be a minus 1. So my answer is 5x minus 1 times 2x minus 3. All right, number 8. Ooh, look at this. There's a big clue here. 4, 26, and 42. They're not all divisible by 4, so I'm still stuck, but they are divisible by 2. So what I should do to make this problem easier, because if I don't, I'm going to have to do 4 times 42, which is 168, and then I'm going to have to list all the factors of 168. That doesn't sound like fun. If I have to, I can do it. But notice how much easier this gets if I notice that they're all even numbers. That means I can factor out a 2 before I even get started, giving me 2x squared plus 13x plus 21. Now, instead of having 168, I've got 2 times 21. I've got 42, which is going to be a lot easier. In fact, I think we already did a 42 earlier, turning into a 13. Either way, I know it's going to be a 6 and a 7. And my signs are the same, both positive. So I'm going to rewrite it. I think the 2 is going to confuse some of you. So just remember the 2. I'm going to ignore it for now, but just don't forget about it as we finish this problem. So I'm going to rewrite this as 2x squared plus 6x plus 7x plus 21. I'm going to group 2x turns into x plus 3. Factor out a positive 7, x plus 3. So my answer is x plus 3 times 2x plus 7. But don't forget about the 2. All right. Last question is, nope, can't factor this one because 39 is divisible only by 3 and 13 and 20 is not. So we are locked into this one. So we're going to have to deal with this, which is 20 times 18. 2 times 18 is 36. So this is 360. Oh boy. All right. Might want to have a calculator handy on this one. Nothing wrong with that. 1 times 360. Now, what's my goal here? I'm looking to add to get 39, so I need to get some much smaller numbers here. So a calculator would be handy. Let's see if I have one handy. I do. I won't need it yet, but let's have it ready to go. Okay. 2 times 180. 3 times 120. 4 times 90, 5 times, let's see, 7 times 5 is 35. Carry them, so 72. 6 times 60. 7, probably not. 8, yes, but now I'm kind of out. So let's go. So I'm going to do 360 divided by 8. So it's 8 times 45. I'm going to do 360 divided by 9. That's going to be 40. Because 9 times 4 is 36. Not there yet. 10. 10 times 36. Maybe 12. 360 divided by 12 is going to be what? I should know this, but my brain's starting to shut down. Is 30. So that doesn't get it. I'm guessing 13, no. I'm guessing 14, no, because we didn't do a 7. So 15. 360 divided by 15 is 24. Hey, there we go. So those are going to add to be 39. Notice I want it to be a negative 39. Signs are the same, both negative. All right, let's rewrite the problem. 20x squared minus 15x. Sorry, computer just locked up on me. All right, let's see if we're back. Minus 15x minus 24x plus 18. In the front, I can factor out a 5x, leaving me with 4x minus 3. I'm noticing that my 24 is a negative. I need it to be a positive x. So factor out a negative. Oh, good thing it's the last problem. My computer's really being bad. Okay, what goes into 18 and 24? 6 does. So I'm going to factor in negative 6. leaving me with 4x minus 3. So the answer is 4x minus 3 times 5x minus 6. All right. Some new steps in here. We're definitely making things a little bit different. But hopefully, if you stuck with me this long, you're like, okay, I got the routine. I can do this. So if you didn't practice these, I'd go back and do them again and then just sort of double check and listen to me go through them, and you'll be fine. Make sure you ask questions in class if you are confused.